First of all, there is a huge amount of activity around generative AI, but there are many other aspects of AI that are equally important and very useful in the practical world. So I want to bring in another aspect which is called adaptive AI. There is recommendation AI. There's so many other aspects which do not necessarily require generative AI and has its own set of algorithms to process them. So one particular topic is the adaptive AI. A couple of years ago, I wrote this book, which is called Adaptive Machine Learning Algorithms with Python. And I provided a whole GitHub with that for all the algorithms and use cases that we have. This is the book. This is the Springer Verlag link to the book. We had over 16,000 access downloads. So it's been fairly popular. So moving on, why do we talk about adaptive AI with respect to generative AI? So I'll first bring out the differences between the two. Then I will point out what are the synergies between the two. So what is adaptive AI? Adaptive AI, it rapidly incorporates fresh inputs from its operating environment to provide more precise results in real time. So you are processing in a sequence, you got a whole batch of data, you trained everything, but suddenly the environment has changed. We do not have sufficient storage and compute and bandwidth to process the data with low latency. So if a huge amount of data came in and high dimensionality data, you cannot quickly retrain the model. It is increasingly considered the next stage in the evolution of artificial intelligence. That's why I wanted to bring in the adaptive AI. The data cannot be batched immediately and needs to be used instantaneously. And then take, for example, a streaming case. You are at a streaming terminal at a grocery store. You're buying a whole bunch of new items. What is the recommendation that the AI engine should provide you for your next purchase or further purchase? What are the coupons they should print for you? The new batch of data came in, you bought 20 items, a huge amount of data. How much did you buy, and so on and so forth for each item? Now you have to process and create a new recommendation. So this data cannot be batched and processed because it has to be done instantaneously. The data changes over time. Today I bought fruits, tomorrow I'll buy vegetables, then I'll buy baby stuff, who knows what, okay? The data volume and dimensionality are large, and we do not have device memory, bandwidth, and power to store or upload the data to the cloud. Almost all generative AI applications are done on data centers or on the cloud, whereas this one will have to be done locally on the spot, and the results are to be generated right away. In contrast, we all know what generative AI is. ChatGPT is an excellent example. It creates new content such as images, text, music, video, code based on the prompts or inputs. It uses ML models to learn patterns from large amounts of data, petabytes of data, and it creates new content. So generative AI is all about learning a huge amount of batched data and then creating new content. And examples are like writing a story, creating an image, creating a new music, creating a new video, or generating new text. So there are significant differences between generative AI and adaptive AI. The learning process is different. Generative AI generates new material using pre-existing patterns and data, whereas adaptive AI is learning from new data and updating the model to increase accuracy and effectiveness. Its applications of generative AI are mostly in the creative domain, content creation, natural language processing, whereas this one is ideal for dynamic environments such as real time decision making, where continual learning is needed. Adaptive generative AI is not very flexible. It has to be trained on large volume of data, whereas adaptive AI is very flexible and can adapt to new data. Complexity. Generative AI requires large quantities of GPUs, has to be trained for days. Adaptive AI will require small compute and has to be trained in a local compute environment. Uh, Nvidia has some edge computation chips for that for special purposes. Use cases are like image synthesis, word generation for generative AI. Adaptive AI is autonomous systems, tailored suggestions, dynamic decision making. So, any questions so far? Okay, I'll move on to the rest of the presentation. So, what are the typical use cases and benefits? So, let's take an example of adaptive AI. In my book, I talked about edge use cases, whereas here we are going to talk about uh, other use cases as well. One is healthcare, personalized treatment, and it adapts treatment plans based on the individual patient data. It is real time monitoring and monitors patients in real time. This is a huge area. In fact, I am working on a um, uh, idea where you can create a healthcare AI for large populations in a country like India. I am contemplating on that project. I have started working on the concept itself. But the healthcare is a very big area. We have AI for creative arts, for images, video, but a lot of the healthcare information data that is or AI is on diagnosis, on creating genetics, drug discovery. But how about generic healthcare for millions of people? That's a very important area that one can think of, that you can adapt to personalized treatment mm, uh, for millions of people with basic AI. Okay. Finance, fraud detection, we know that case. Investment decisions, analyzes complex market data, the current situation, people's personal needs, and create a solution. Risk management, continuous learning, and adapts to changing market conditions. Supply chain, predictive maintenance. In fact, I have a public open source information, not code, but information on data center service assurance. And I can show you how that can be used with basically adaptive AI can be used for predictive maintenance, demand forecasting, inventory optimization. Same with transportation, traffic optimization, personalized navigation, predictive maintenance. Other applications are like various applications like e-commerce, cybersecurity, sustainability. So there's lots of applications of adaptive AI that we can think of. None of these can be easily solved with generative AI. What are the key benefits of adaptive AI? It improves the accuracy and performance. It creates enhanced personalization. It increases efficiency and productivity. It creates real-time decision-making capability. It is also scalable and adaptable, and it reduces cost. So, for example, if you can provide personalized medication for a large set of customers, then you can reduce the cost significantly. I have a little graphics for a personalized medication. Uh, I don't know if you can see that very well, but let's say a patient uploads their personal data into the database, and you can process it and you can create a patient profile. Then the patient has certain other conditions that have come up, sickness, that they upload to the portal, and the portal can recommend tests based on AI. So, first of all, like the previous gentleman is saying, all the documents can be processed, all the images can be processed, and a person's profile can be created. And then a sickness recommendation. This is a very adaptive situation in current conditions. And you don't have to provide a diagnosis, but you can create a doctor's appointment. So if your AI is used to process the data and build the profile, AI is used to create a recommendation of tests, and AI is used to choose the appropriate doctor and provide a concise list of items that the patient has, so that the doctor can get a concise information. Right now, the doctor gets a huge amount of data uh, uh, or electronically, or in a country like India in a file, and then one hospital doesn't connect to another, and then you look at one or two pieces of information and you do the diagnosis. Here, AI can look at the entire history, the current condition, and create a precise a summarization of the patient's history to the doctor, and the doctor can do a video visit. So this mechanism can significantly enhance and reduce cost in AI. So that's a reduced cost is a very significant, especially for large populations. What does generative AI key use cases? Content creation has primarily been the primary use of generative AI. You can generate text, you can create a new business plan, you can write poetry, you can write text, you can write your performance reviews. A lot of people are doing that these days. This is not the most productive use of AI, but it is certainly engaging, and it certainly creates a lot of people interest. Visual arts, this is a creative aspect. Music composition, all these are examples of generative AI. The other important use of generative AI is data augmentation. Data augmentation is generating synthetic data that mimics real world example. It helps expand existing data set, addressing the limitations of scarce data. This can significantly improve the performance and accuracy of all other applications. It can also help in scientific discovery, and it has the potential to accelerate scientific research and create novel molecules, materials for desired properties. So this is for drug discovery as well as for disease diagnosis. But I'm going to focus a little bit more on the data augmentation part. This is a very important aspect of generative AI. So, any questions? I can stop here and take some questions if somebody has any questions. I see there are two questions.
The best
Adaptive
thing
AI.
to do is, Dr. Chatterjee, they may not be able to uh, get to speak. They have to type it in. So we'll wait
Yeah,
for.
I see the questions. I see the
Oh,
questions.
any
Yeah.
questions coming in?
So Nvidia has what is called the Jetson. Okay. Nvidia, if you type in Nvidia Jetson, it is a uh, uh, Nvidia GPU on demand for edge computation. So this is a Nvidia for robotics as well as edge use. This is a good example of an Nvidia product uh, for edge. That was the first question. For what are the NVIDIA tools that are there for edge computation, Jetson, Orin, Nano. All of these are, I'm not personally too familiar because I work in the data center area, which involves the Hopper and the Blackwell, but that's been the biggest growth area. But in terms of the NVIDIA edge computation, Jetson has been a key product. Now, let me ask Amazon already provides recommendation features on their e-commerce website. It provides recommendation in real time. What can be done by Amazon with respect to adaptive AI recommendation feature? Very good question. So, recommendation, I actually wrote a Medium article on a recommendation engine. Let me find that article. And I provide a real-time recommendation engine example. Okay, let me pull that up and share. You can see my screen, right? When I pull the recommendation, ML-based consumer recommendation, can you see this?
Yes, we
Can
can. We are able to see.
somebody give me a nod? Yeah.
We are able to see.
Okay. So ML-based consumer recommendation. This gives us a bunch of techniques, and I can actually post this article also. Chat window. I'll post this article right here so people can pick it up. So so here I've given 8 different types of recommendations. YouTube recommender, wide and deep learning, neuro collaborative, Alibaba transformer, Netflix price, Spotify recommender, Facebook recommender, and Nvidia DLRM. Okay. This is the high level picture of the recommendation. This is using the deep learning methods. But what I would like to go into is the inference pipeline. It's a little bit hard to see, but in this article, I've described the inference pipeline. The inference pipeline consists of real-time recommendation, where you get the user application, you embed the items, and you get the candidates, then you do the ranking, and then you do the modeling. Then you provide the recommendation. So the inference, a lot of people talk about the recommendation algorithms, but do not discuss the inference part. The inference part is where adaptive AI can be further used in order to do better candidate generation and ranking model. It will take me a whole 1 hour to explain that, but feel free to read this paper. It talks about a recommendation technique by which you can generate candidates and ranking a model. I did not discuss a lot about adaptive AI, but you can easily surmise from this paper how you can use adaptive AI in this. Okay, so that's a good article to look at to answer your question on that. Any more questions? 2 questions. Okay, good. So there's another paper I would like to recommend reading. It is for service assurance. Let me find that paper for a second. I should have come prepared on that. Let me, oh shit. You can only see my screen with the saying generative AI key benefits, right?
Yes, Chanchal. Yeah, key benefits.
Okay. Okay. Because I'm also looking at another paper. I've also done quite a bit of work on MLOps, so I'm going to quickly pull that article. Give me 1 more second. Okay, blog. So there is this blog I had written when I was at Google. That was before I joined Nvidia. And this is a event monitoring with explanations on the Google Cloud. So this is a good example of how real-time decision making is done for service assurance, for data center management. And I'm going to also place this article in the chat window so people can look at it later on. So we have, with generative AI, we can generate more creativity, increase the efficiency, because you don't have to write code from scratch, or you don't have to write articles or business plans from scratch, personal experiences can be created, new photos, new videos. It's accelerating innovations and discovery of novel material molecules. It certainly does cost reduction because of increased efficiency and accessible enhancement. So, how do the two help each other, adaptive versus generative AI? Adaptive and generative AI can complement each other. For example, generative AI can generate data, synthetic data, for adaptive AI to quickly adapt to. And generative AI can benefit from adaptive AI techniques that optimize content generation processes based on real time feedback. So I'm at a grocery store and I'm buying a whole bunch of items, or in an e-commerce store, I'm buying a whole bunch of items. This is where the new data that goes into the generative AI algorithm can quickly update itself. So an adaptive edge of the generative AI. So if you look at the generative AI as a whole algorithm base and data used for that, adaptive AI can be a little front end of that, which can quickly give feedback to the generative AI in order for it to come with a better set of recommendations or whatever suggestions that generative AI could create for that person. Okay. And that is where the adaptive AI can complement generative AI. This is where things are moving and will eventually go there. So generative AI, on the other hand, can generate new data for adaptive AI to create. And adaptive AI can provide new data for generative AI to change its decision. So this is basically an area of synergy between the two. So I'll give you an example of how this can be used in real world application. This is anomaly detection. This is CPU usage over time. Okay, very similar to this ML monitoring algorithm. This is the paper, this is the blog I wrote. The algorithm is different from what I'm showing here. This is a little bit more complex, but the same deep learning algorithm could be used here. This is a simple median. So generative AI can provide you data to kickstart the algorithm. The algorithm on an adaptive basis computes the median and looks at every sample, how it deviated from the median. And it keeps going. So the data is coming real time as well from the generative AI. And then you find a spike and you say, here's an anomaly, and you keep moving forward. So this is where an adaptive AI can quickly detect anomalies, and generative AI can generate data for this anomaly detection algorithm in real time. Another use of adaptive AI is data compression in real time. So this is a very complex data at the bottom, a signal. Okay. How do you do 8x compression at the edge? Because edge does not have enough memory, power, and volume to store all this data. This data is coming in real time. This might be a person's behavior or sentiment, and the sentiment data is coming rapidly, high dimension, thousands of people. How do you compress it? So in order to compress it, 8x compression, adaptive AI can provide efficient algorithm. That's what I have in my book. This is based on what is called principal component analysis, which will give you, it is not a perfect compression, like it has another extra line here, but it's more or less pretty good compression. Here are some characters, handwritten characters coming in real time. This is the original data. This is compressed 8x with the with the adaptive AI. So the adaptive generative AI can provide as much data as possible. It generates. Adaptive AI can help find anomalies, compress the data, adapt to the stochastic nature of the data, because data is always non-stationary. As you can see, the 9 changes in so many ways. And this can be nicely generated by generative AI, whereas adaptive AI can compress it. So I have 4 more minutes, and I have reached the end of my slide deck. Any other questions?